All right, ladies and gentlemen, for this presentation, we're going to talk about a really key aspect of what happens to matter during chemical reactions. So first, a quick review. Chemical reactions cause chemical changes. So they cause changes in matter. Whenever a chemical reaction occurs, you start the reaction with what's known as reactants, and you end the reaction with what's known as product. Typically, all of the reactants are no longer the same matter, but sometimes it's only one or two of the reactants. It depends on the chemical reaction involved. But the key idea here is matter is changed. All right. The matter that you begin with is not the same form as the matter that you end with. Atoms get combined, atoms get separated. The key idea here is atoms get rearranged. All right. Now, this is important. When I say atoms are combined and separated, what I mean is like they're combined in different ways and then separated and recombined. This doesn't actually break atoms. That would be something else entirely. It just takes atoms as if they're little pieces of Lego and reassigns them and reconnects them in all kinds of different ways. Now, one of the key aspects about chemical reactions is that energy is always involved. There's two things in this universe, matter and energy, and they're all involved when chemical reactions are in play. When it comes to chemical reactions, two things happen. Either energy leaves the reaction, so the reaction happens and energy is given off. Think burning wood in a fire, all right? That is known as an exothermic reaction. Thermic, right here, means heat, which is a form of energy. And exo means out, so heat out, energy out. If energy enters a reaction, again, we have thermic, and we have endo, which means energy in. All right, so endo means in. So energy, there's always energy in reactions. In exothermic reactions, energy goes out. In endothermic reactions, energy goes in. So chemical reactions always involve matter and energy. Energy either goes into the reaction and makes it happen, or the reaction happens and energy comes out. But no matter what, when a chemical reaction occurs, matter has been changed. It has been rearranged into something new. All right? And that's going to be the focus of what we talk about today. Matter is rearranged in chemical reactions. That matter is changed. It starts in one form and it ends in another form. But one of the key things here is during chemical reactions, the form of the matter will change, but not the amount of the matter. Okay? You have a certain amount of atoms at the beginning of a reaction. That amount of atoms must be the same at the end of the reaction. Now, sometimes they will change to different molecules, different combinations of atoms. Sometimes the atoms that were combined will be separated off. They won't always be in the same state of matter. Sometimes you'll go from solid to liquid, or from liquid to gas, or from solid to gas. But no matter what, you will start and end with the same amount of matter. And that's known as the law of conservation of mass. If you recall, one of the things that we discussed, particularly when discussing chemical reactions, chemical changes, physical changes, even density, mass is a measure of the amount of matter. So the law of conservation of mass basically just means that when a reaction happens, the amount of matter is unchanged. Okay? When a chemical reaction happens, you must start with the same amount of matter that you end with. Let's take a look at an example. So here, this is actually an example that we saw in an earlier presentation, specifically called electrolysis, where you use electricity, our little yellow lightning bolt there, to take water molecules and break them into hydrogen gas, the diatomic element, and oxygen gas, the diatomic element. Now, we used this as an example before to talk about the difference between physical and chemical changes, but it is also instructive when attempting to think about what it means for the law of conservation of mass. You'll notice on the left I have 6 H2O molecules, all right? 1, 2, 3, 4, 5, 6. And on the right, I have 1, 2, 3, 4, 5, 6 H2 molecules and 1, 2, 3 O2 molecules. So just at a surface glance, it looks like I now have more matter. That this chemical reaction has created a situation where I have more matter. But if you look over here, if we did a atom inventory, you notice that 6 H2 molecules has 6 oxygens. 3 O2 molecules on this side has 6 oxygens. So the number of oxygens has not changed. Law of conservation of mass. Over here, my 6 H2O molecules have 12 hydrogens. Here, my 6 H2 molecules have 12 hydrogens. It has changed form, but I still have the same number of hydrogens. The law of conservation of mass. The amount of matter on the left is, or the reactants, is equal to the amount of matter on the right, or the products. The matter has simply rearranged. And this matter has particularly changed state. The water on the left is a liquid. The substances on the right are actually a gas. And frequently that actually leads us to confusion because let's say, for instance, you burn a log. If you were to measure a log prior to lighting it on fire, you'd have a mass. And if you burn the log, at the end, if you measure it again, it will have a lower mass. So naturally the conclusion is, oh, well, it lost matter. But it didn't. Because while the log was burning, smoke was given off. That's a gas. All of the mass that is lost in the log is lost as gas or soot. So it didn't vanish. It's still there. We just didn't trap it properly. And so that's the key idea here. We have this idea of the law of conservation of mass. And basically what it's telling you is you start with an amount of matter in the reactants and you end with the same amount of matter at the end. Or the mass at the beginning must be equal to the mass at the end. And if it does not equal, you didn't measure something right. Or something escaped, as if it turned into a gas. All right, that's the law of conservation of mass.